Welcome, Tactical Technician, Diagnation. The sun is going down, and we're going to talk about high-speed CAN and math channels. Basically, we're going to look at this. It's a small topology as far as high-speed CAN. It's between the gauge control unit and the PCM. We're going to scope the on that blue channel, the high side of high-speed CAN, and on the red channel, the low side of high-speed CAN. Don't disregard what you see here as far as micro clamps that didn't bear fruit, maybe in the future, but nonetheless, we're going to get onto the scope and start to take a look at certain things. So we want to. Okay. You can see we got a frozen screen. We have CAN high and CAN low. And we'll talk about certain things. I believe it's 500 kilobytes per second. That's the speed, but basically we're going to see when we get it running, we want to let me start the car and get the thing running, and then we'll stop it and enter the math channel into the equation, because it gives us a diagnostic advantage basically. And I'll go to a smaller time. Okay, there's 20 milliseconds per division. Now we'll stop the screen. All right, we can basically see what we when we see the packets, the data packets going across the screen. I'm also I got my sample rate jacked up pretty good for this because of the high frequency of the signals. Basically, I want to talk about the voltages, because when I bring the math channel into the equation, it's going to be an A plus B math channel. So we're going to add the sum total of the voltages. So basically, whatever voltage here, right here, and I go one bit at a time, or byte. Correct me on that, a bit or a byte. It's basically a recessive or a dominant right here. If we add this voltage to this voltage, the sum total of that will be the same is if we add this voltage to this voltage in this bit. And we go down the line, this voltage and this voltage will be the sum total, will be the same. So on a good network, our math channel is going to be a straight line. So I'll bring the math channel into the equation, see how this works. Tools, math channels, A plus B, or on burgundy, the math channel is burgundy. So now we got a nice straight line. Let me start it up. We'll see. Okay, we got a good straight line. What do we do? Okay, we got to get a... Something's going on here. You probably can see what's wrong. This is what's going on. Got my microscope. I'm gonna turn that off. So basically, we can see our math channel, which is our sum total of our network, of the two parts of our network. So if we're troubleshooting a situation where we have intermittent communication, or the network may be going south, occasionally there's a sore spot in the wiring or something, this is a good way to watch it, is with that math channel, because that math channel, as I said, should be a straight line, because the sum totals of the voltages on a good network is the same. So let me do something to the network. I'm gonna go up to about 10 milliseconds per division, and I will mess with the network, and we'll watch the math channel. I will bring it to ground. I am on the, I will start out with the, that is the high side, and I will bring it to ground intermittently and look at what happens to the math channel. Okay, right there. You can see it. Let me stop the scope and roll it back. We can see how, right here, we can definitely see how bringing the blue side to ground affected the math channel. So it muddied up that equal calculation of like the sum total of the voltages on the high and the low side. So that's something to just, you can watch that. They look about the same, and I will start the scope again. and we can see we have a good network. I will bring the other one to ground and see what happens. Okay, you can see going across the screen. Now we're going to go to ground here. Okay, stop the scope, roll it back. There we go. See, our math channel real low there because we had a disturbance of the balance of the network. I'll really open it up there and you can see right there it get muddy. So as far as using the scope, when we're looking at networks and we're looking at the dual networks, consider that math channel to give you a diagnostic advantage. Thank you very much.